Okay, so this is section 4.3, which is modeling arithmetic sequences. And this notes is going to look a little bit different because most of it we're actually using from the book just because it was easier than drawing all these graphs and charts in. So I labeled it with the page number, which should hopefully make it a little bit easier. So we're going to start off on page 175 with this Explore. So it says you can model real-world situations and solve problems using models of arithmetic sequences. For example, suppose watermelons cost $6.50 each at a local market. The total cost in dollars of n watermelons can be found by C of n equals 6.5 n. So basically, we want to fill out the chart. So n represents the number of watermelons, and C of n represents the cost. So for one watermelon, it will cost $6.50, and then you basically just keep adding 6. So 2 watermelons will be $13, 3 watermelons will be $19.50, and 4 watermelons will be $26. So the common difference would be 6.5 because each time we're adding 6.5. What does n represent? So n represents the number of watermelons. So if I want to know how much it costs for 100 watermelons, I would plug in 100 for n. What are the dependent and independent variable? So we have independent and dependent. So think about what depends on the other. So the independent would be the watermelons, because that can stand on its own. The dependent would be the total cost. So the total cost depends on the number of watermelons. And lastly, we're going to use our equation to find C of 7 and what this represents. So C of 7, since it's C of n equals 6.5n, C of 7 equals 6.5 times 7. So C of 7 will equal 45.5. And what that represents is it will cost $45.50 for 7 watermelons. Okay. So next is modeling sequences from a table. So this was kind of like a little introduction. Now we're going to be modeling sequences from a table, from a graph, and from a situation. So we'll look at the table first. So we have a table which represents the distance in miles from the store after Mila had traveled for n hours. So after 1 hour, she was 20 miles away. After 2, 32 miles, and so forth. So it says to construct an explicit rule and function notation for the arithmetic sequence represented in the table, then interpret the meaning of the specific term of the sequence in the given context. So first, let's kind of find the common difference. So what's happening as I go from 20 to 32 to 44 to 56? I am adding 12. So that's our common difference. The next thing we want to do is find an explicit rule. So for the explicit rule, we know that it's going to be f of n equals the first term, which is 20, plus the common difference times n minus 1. So that would be the explicit rule. I'm going to actually also come up with the recursive rule, even though it doesn't ask. So the recursive rule would be f of 1 equals 20, and then it would be f of n equals f of n minus 1 plus 12. Okay, so lastly is to solve for f of 10. So if we find f of 10, that would be 20 plus 12 times 10 minus 1, which is actually 20 plus 12 times 9. So we definitely want to make sure that we do 12 times 9 first and then add that to 20. And so we get 128. So what does that mean in the context? What it means is Mila is 128 miles from the store after 10 minutes. So that's what we want to do when it says interpret. That's very important. Okay, so this was creating a sequence from a table. So now we're going to create a sequence from a graph. So it's pretty much the same thing. Construct an explicit rule and function notation for the arithmetic sequence represented by the graph. Okay, so the first thing that we want to do is find the common difference. So we want to see what's happening from 34 to 51 to 68 to 84. So how you could do that is just do 51 minus 34. So the common difference is 17. Okay, so now let's go ahead and come up with our explicit rule. So our explicit rule is f of n equals, we have our first term, which is 34, plus 17 times n minus 1. Then we can come up with a recursive rule. Our recursive rule is f of 1 equals 34, and then f of n equals f of n minus 1 plus 17. And lastly, we want to find the height of the stack with 7 boxes. So basically, we want to find f of 7. So that would be 34 plus 17 times 7 minus 1, which is 34 plus 17 times 6. And when you do all that, you get 136. So what that means is the height of the stack of 7 boxes is 136 inches. Okay, so this was creating a sequence from a graph. And lastly, we are going to create a sequence from a situation. So it says, Ruby signed up for a frequent flyer program. She received 3,400 miles for the first round trip she takes and 1,200 frequent flyer miles for all additional round trips. How many frequent flyer miles will Ruby have after 5 round trips? So basically, kind of what I gathered is that the first term is 3,400, and then I also gathered that the common difference is 1,200. So if we were to write our explicit rule, we would have f of n equals 3,400 plus 1,200 times n minus 1. Now, if we were to come up with our recursive rule, it would be f of 1 equals 3,400, and then f of n equals f of n minus 1 plus 1,200. Now, to find out how many miles she would have after 5 trips, we're going to do f of 5, and we will use the explicit rule. So it'll be 3,400 plus 1,200 times 5 minus 1, which is really 3,400 plus 1,200 times 4. Remember, you will do 1,200 times 4 first, and then add the 3,400, and you end up getting 8,200. So after 5 round trips, Ruby will have 8,200 frequent flyer miles. I'm going to abbreviate that, FFM, frequent flyer miles. Okay, so again, what we just did was looked at sequences from different types of representations.